Here we're going to talk about factoring a perfect square, and only ones that have a leading coefficient of 1. So the big thing is this isn't any different than our factoring normally with a leading coefficient of 1. We're just kind of guessing and checking. The only difference here is if these turn out to be perfect squares, we might notice a nice pattern in our guessing and checking, but in general it's still the same idea. We need something that multiplies to positive 49, because that's our last term, so our two last numbers, and I need something that adds to negative 14, so two numbers that make that work. So first thing I know, if I'm setting this up, what did it look like before it was FOILed? I know my first two terms are w and w, because w times w gives me w squared. And since it's just a 1w squared, that's kind of my only option. Alright, so now I need two numbers that multiply to 49 and add to 14. So 49 and 1, 7 and 7, and so 49 and 1 definitely won't add to 14. 7 and 7 seem like they work. And then be careful about the signs. To multiply to a positive, it could be two positive numbers, but see how that wouldn't add to negative 14? So what if we try two negative numbers? So negative 7 times negative 7, the negatives cancel, multiplies to 49. Does that add to negative 14? So our inside-outside terms are negative 7, negative 7. That looks like it would add to negative 14. So we solved the mystery. One thing in these is the coincidence here. Since it happened to be a perfect square we started with, our two factors are the same. And so to simplify even more if we want to, because we like to write the least amount possible or keep things as simple as we can, if we have something times itself, w minus 7 times w minus 7, the shorthand way to write something times itself is squared, right? We don't normally write x times x, we write x squared. And so if I happen to have a perfect square, I can write it as squared in my end answer instead of leaving it how it is. So w minus 7 squared is the most simple way to write that. So not any different than regular factoring, just maybe eventually this, if you recognize them, they turn out easier because the two numbers that you're looking for end up being the same two numbers. So let's try another one. What did it look like before it was FOILed? So I'll set up my parentheses. I know the only way to get x squared as my first term is x times x. So what multiplies to 1 and adds to 2? Well, the only factors of 1 is 1 times 1. So let's try it and hope that that works. So if I think x times x is x squared, my inside term is 1x and my outside term is 1x, what happens when I get those like terms together? 1x plus 1x gives me 2x, and my last term is 1 times 1. So I'm thinking about foiling, I'm checking does that actually work, and then I notice since I have x plus 1 times itself, a shorter way to write that would be x plus 1 squared.